Good morning, dear students. So in the previous classes we have studied about differentiation. Okay, have you remembering it? Yes. So differentiation, you know what is differentiation, how will you find the derivatives, and also differential equation is now our today's topic. So differential equation is related to differentiation. Okay, derivatives. Here also we have talking about derivatives. Okay, so let us start our chapter. A differential equation is an equation that involves independent and dependent variables and the derivatives of dependent variables. Okay, so the equation contains. What does the equation contains? It contains a independent and dependent variable. Okay, two types of variables you know about, dependent and independent variables, and the derivative of the dependent variable is here. Okay, so those equation which contains these three things, that is a differential equation. Okay, dependent variable and independent variable, and there should be a derivative for the dependent variable. What is the derivative of a dependent variable? I mean any variable. It is of the form d by dx. It may be y, it may be z. It is according to the dependent variable. Okay, so that is differential equation. And order of a differential equation. Okay, order of a differential equation. It means the order of the highest derivative occurring in it. It has been there should be a derivative, and what is the order of that or the highest derivative? You know about the highest successive derivatives we have studied. First order derivative, second order derivative, third order derivative, and the successive differentiation we have studied. So there should be nth order. Okay, so that highest derivative is the order of the differential equation. Order of the differential equation. And also there should be a degree for the differential equation, that is the degree of the highest, okay, the degree of the highest derivative order. Okay, the derivative of highest order and which is occurring in it after the equation is freed from radical signs and fractions in the derivative, if any. In short, it means there should be a highest derivative order. That means order is there, and what is the degree of the derivative? Okay, that is the, I will give examples, then it will be clear for you. For example, first there should be, has given dy by dx plus y sin x is equal to cos x. So what is the order and degree of that differential equation? Is it a differential equation? Yes, there is a dependent variable. What is that? Y. There is an independent variable x, and there is the derivative for the dependent variable dy by dx. Okay, so what is the order? What is the highest derivative there? Dy by dx. It is of the order first. So the order is 1. And what is the degree? Dy by dx. It is simply dy by dx. So the order and degree is 1. Okay. Next, okay. So d square y by dx square plus 9x cube is equal to 0. Okay, that is, and sorry for the disturbance. Okay, sorry. And we're continuing. D square y by dx square plus 9x cube is equal to 0. That is the next equation. Here, what is the highest derivative? What is the highest derivative? It is 2. That means it is second derivative. So the order is 2. But what is the degree? Degree means the derivative of the highest order which is occurring. How many times the degree, the highest order derivative is occurring? That is the degree. So how many times that is occurring? Only 1 times. Okay, so the degree is 1, but the order is 2. Okay. Next, I will clarify this next. X square into d square y by dx square the whole square plus 5y dy by dx is equal to 7x square y square. Here also, what is the order? It is 2 because there is second derivative. So, second derivative is there. So, it is the order is 2. But the degree, what is the degree? Degree is also 2 because d square by dx square is occurring 2 times. Whole square is there. So, the degree is 2. Okay. Is it clear? Order and degree. Okay. And a differential equation is said to be linear if it's said to be a linear differential equation if the dependent variable and all its derivative occurring in the equation which is occur only in the first degree and are not multiplied together, which means, okay, that is the dependent variable is there and its derivative occurring in the equation should be of the first degree. A first degree derivative is first degree and the dependent variable is there, okay, and independent variable also, if that equation is said to be linear equation. Okay, for example, dy by dx is equal to sin x. What is the degree? It is the first degree. So, first degree equations are linear equation. First degree means first derivative. It is also order. First order equations are linear differential equations. Okay. And next is when will be it will be non-linear. Okay. If its degree is more than 1, degree is more than 1, and also any of the differential coefficients, which means dy by dx or d square y by dx square, which has exponents more than 1. That means the degree is more than 1, and also the exponent of the dependent variable is more than 1. There is a dependent variable and there its degree is more than 1. And the product containing dependent and its differential coefficients are present. Then how we can say it as will be non-linear equation. For example, d cube y by dx cube the whole square minus 5d square y by dx square minus 7y, which is a non-linear equation because it is the degree is more than 1 is, and also d cube y by dx cube has more exponent than 1. Okay, that is, it is a non-linear equation. So, that kind of equations are non-linear equations. So, linear, non-linear equations. Okay, is it clear? Yes. The examples are there. Find the order and degree of the given equations. Okay. So, I think order and degree has clearly get for you. Okay. Next is, the answer is there. Next is the formation of differential equation. How will you form a differential equation? So, differential equation can be obtained by eliminating the arbitrary constants from a relation in the variable and constant. That is, if an equation contains n constants, then differential equation will be of nth order. Okay, the number of constants is dependent on this. If the equation has n constant, it is an nth degree equation, or sorry, nth order equation. Okay, and that is, there is a working rule given there. Differentiate the given equation. How will you form differential equation? That is the steps is given there. Differentiate the given equation with respect to x successively a number of times equal to the number of arbitrary constants to be eliminated. So, equation contains arbitrary constants. Okay, you have to find the derivative until the arbitrary constant is eliminated, is not there. You have to eliminate the arbitrary constants there. Then that number of times you have to find the derivative. And then eliminate the arbitrary constant from these equations and the given equation. Okay, that is these equations means those equations which are differentiated and from the given equation, and the eliminant is the and as we eliminate the constant, that equation is the required differential equation. Okay, and the order of the differential equation should be equal to the number of arbitrary constants in the given equation. Okay, as we do problems, you will get understand. Okay, that is, find the differential equation representing the family of curves v is equal to a by r plus b, where a and b are constants, arbitrary constant. So there is two arbitrary constant. So what you have to do is you have to differentiate the given equation 2 times. Okay, that's what I'm saying. Okay, that's the number of arbitrary constant is 2. So you have to differentiate the given equation 2 times. Okay, so v is equal to a by r plus b. Okay, then the given equation, you have to write the given equation as this, and to find the differential equation of the above curve, differentiate with respect to r. So what is the a and b are constants. So r is the dependent variable. So you should take r as the dependent variable and then find the derivative. dv by dr, what is that? Minus a by r square plus 0, because yes, b is constant, so it is 0, and that is dv by dr equal to minus a by r square. Okay, and then find d square v by dr square by derivating once again with respect to r. We get d square v by dr square is equal to 2a by r cube. Okay, and substitute the value of a from the first equation. What is the value of a? It is minus r square into dv by dr. Then you will get d square v by dr square is equal to 2 by r cube into minus r square dv by dr. Then you can cancel r. From that you will get what is d square v by dr square plus 2 by r dv by dr is equal to 0. Okay, that is the differential equation. So there are two constants, so you have to find the second derivative. Okay, second, so it is the second order differential equation. It is the second order differential equation with degree 1. Okay, with degree 1, and it is a linear equation, linear differential equation. Okay, so linear differential equation. Okay, this is how you have to find the differential equations. And next, so we have study how to form a differential equation. Now, how will you solve? What is the solution? How will you solve the differential equation to find the solution? So solution or integral of a differential equation is a function of the form y is equal to f of x, which satisfy the given differential equation. Okay, so differential that is as we know, but how will you when will you say a function is equation is satisfied? When yes, the given equation we have root. You know about roots. Okay, that means a polynomial has root. Polynomial equations has root. When will we say that the given is the root of a polynomial equation? Yes, you have to satisfy the given equation by the roots. So like same wise here also, if the differential equation is satisfied, then that function is the solution, and that function is of the form y is equal to f of x. Okay, and the solution of a differential equation does not contain the derivatives, that you have no. Always solution is always of that is of a function which does not contain any derivatives. Okay, for example, y is equal to a cos x plus b sin x is the solution of the differential equation d square y by dx square plus y is equal to 0, because dy by dx is minus a sin x plus b cos x, and d square y by dx square is minus cos x minus b sin x, which is minus a, taking the minus y. So yes, y is equal to a plus bx is the same as the equation is satisfied. Okay, y is given find the dy by dx and then dx by d square y by dx. Then substitute that equation into the given differential equation, that is equal to 0. Okay, minus y plus y, which is 0. Okay, so the differential equation is satisfied. That is, so y is equal to a cos x plus b sin x is the solution for the given equation. Similarly, xy is equal to sin x is the solution of d square y by dx square plus 2 by x into dy by dx plus y is equal to 0. So how will you find the solution? That is the next thing we have going to study. The number of arbitrary constant in a solution. That is, suppose a solution, a second degree equation in polynomial 2-degree equation is there. So how many roots are there in that for that equation? 2 roots. So similarly, in case of differential equation also, how will you find how many number of solutions are there? For that, a solution which contains n arbitrary constant. You have to eliminate the n arbitrary constant. So we need n plus 1 equations. If you have to eliminate the n constants, there should be n plus 1 equations are there. That is, the given relation along with n more relations obtained by the successively differentiating it n times, which means n plus 1 equations. So the differential equation is obtained clearly a nth order 1. Okay, so hence a solution of nth differential equation contains n arbitrary constants. So there is the arbitrary constants. Similarly, okay, the arbitrary constant has been there for differential equation, not the roots. Okay, that's the difference. Now, what are the general and particular solutions? For a differential equation, there is general and particular solution. So, what are that? What is that? A solution of a differential equation which arbitrary constants is equal to the number of is equal in number to the order. Okay, arbitrary constants is the equal in number to the order, then it is the general solution. Otherwise, other solutions, that is obtained by giving a particular value to the arbitrary constant, is the particular solution. Okay, that is the general solution. If there is arbitrary constants are there, it has no value, then it is general solution. If there is a particular value for the arbitrary constant, it is the particular solution. Okay, that is, and most general solution of a differential equation of nth order must contain n and only n independent arbitrary constants that we have studied also. Okay, so n arbitrary nth order, for an n order differential equation there is n arbitrary constants, and for that, eliminating that n arbitrary constant, we use there is n plus 1 equations there. Okay, these are the things you should have to be remember while doing problems. Okay, now how will you solve differential equation? So you know differential equations, there are 3 standard forms for differential equations. That is variables separable, homogeneous equations of the first order, and linear equations. You know about linear equations then. And variable separable, homogeneous equations, and linear equations are the standard forms of differential equations. Okay. And next, so we have going with variables which are separable. First one, differential equations in which variables are separable. That is the first form. That is, equations which can be expressed that the coefficient of dx is only a function of x and the coefficient of dy is only the function of y. That type of equations are variable separable. That is, it is variably separated. So you know there is two variables there, independent and dependent. If the dependent variable and its derivative and its coefficient, the derivative and its coefficient is only the function of that variable, and then another one. If it takes the coefficient of dx and it is only for x, function of x, and coefficient of dy is a function of y. Okay, we have saying the coefficients. For example, f of x dx. F of x means function of x, and into dx plus f of y into dy is equal to 0. Such equations are variably separable. Okay, so it is variable separable equations. And how will you solve it? Okay, so equations of the form. If you have given a differential equation, you have to identify which standard form that differential equation belongs to. Okay, either it is a variable separable, or homogeneous, or linear. According to that, you have to find the solution. Okay, and how will you proceed it? So the procedure is, separate the variables x and y, that is, associate all the functions of x with dx and all the functions of y with dy, and you know how the differential equations of the type, that is, f of x dx is equal to f of phi of y dy. Phi is a function of y. Okay, so fx dx is equal to phi of y dy. That is the first step. You have to separate the variables of x and y. Okay, x should be in the right, x should be in the left of the equal sign, and y should be in the right. So you have to first separate it, and then integrate both sides and add an arbitrary constant on both sides, on one side. Okay, so your second step is integrate both sides and just add an arbitrary constant. You know, file integration, there should be a constant of integration, and that is add on one side. That is okay. And the procedure 3, then for finding the particular solution, the values of x and y are given. That is, find the general solution containing an arbitrary constant c. That is, you have to, when you integrate, you will get it. And in general solution, substitute the values of x and y, find the value of arbitrary constant c. That will be clear in while you have doing the problem. And now substitute this value of c in the general solution, you will get the particular solution. Okay. So we have going to the dy by dx is equal to f of x. Okay, this is the first step. So find the general solution. This type of questions are given. Okay, find the general solution of each of the following. First one is, dy by dx is equal to x raised to 5 plus x square minus 2 by x. So in the right side, it is a function of x, and dx is in the denominator of the left side. So first you have to do it, separate that. What is dy is equal to x raised to 5 plus x square minus 2 by x into dx. That is the first step. Okay, now integrate both sides. Integral of dy is equal to integral x raised to 5 plus x square minus 2 by x into dx, which implies, what is the integral of dy? It is y is equal to x raised to 5, x raised to 6 by 6 plus x cube by 3 minus 2. 2 is a constant, and the integral of 1 by x is log x, and plus c. So we have putting the constant of integration only one side. Okay, that should be here clearly defined. That is, y plus c is not taking, you have just putting the c on right side. Okay, then that is the answer. So y is equal to, so you have to find the general solution. This is the general solution. First you have to separate the function of y and function of x on both sides, and then you have to integrate and add the constant on the right side only. Okay, yes. This is the first step. And next is the second type, that is, if it is a function of y, then dy by dx is equal to f of y is the question. Then what you have to do is First you have to separate, that is dy by dx plus y is equal to 1. So dy by dx is equal to 1 minus y. Then dy by 1 minus y is equal to dx. That is 1. That is 1 by y 1 minus y into dy is equal to dx. Then take the integration. Integrating both sides, you get x is equal to minus of log mod 1 minus y plus c. That is the required solution. Okay, is it clear? Okay, these two kinds of questions are given. So using this, please do these problems. Next is the type 3. dy by dx is equal to fx into f of y, sorry, phi of y. That is a function of x and product of a function of x and a function of y. Then what you have to do? That is, you have to separate the function of x in one side and then y in one side and integrate it. Okay? Okay. Y into 1 plus x dx plus x into 1 plus y dy is equal to 0. So first put the equal to sign, that is y into 1 plus x dx is equal to minus x into 1 plus y dy. Then cross multiply this, we get 1 plus x by x dx is equal to minus 1 plus y by y dy. Then integrate. Okay. Yes. Next is, okay. Yes. Next is the problem continues, and next is the initial value problems. What are initial value problems? That is a first order differential equation initial along with an initial condition. What is initial? Yes, it is 0. Always initial is 0. So if you have given a question of differential equation and then you have to find given the initial value condition is given, that is the initial value problem. How will you do that? First equation is e raised to dy by dx. E raised to dy by dx is equal to x plus 1 and then y of 0 is equal to 3. The initial condition is y of 0, which is 3. Okay, so the initial condition is given. Then what you have to do is e raised to dy by dx. We have to take the reciprocal, that is log e raised to dy by dx is dy by dx. Okay, then that is log of x plus 1. Then similarly separate that and then integrate, you will get the answer. Okay, and when you find the answer, okay, y is equal to, that is the answer, y is equal to x log x plus 1 minus x plus log mod x plus 1 plus c. That is the answer. So in the answer you have to put y is equal to 3 when x equal to 0. So the x values are 0 and the y value is 3. So c is equal to 3. You will get the constant c is equal to 3 and then substitute that value in the general equation. So that is the particular solution. You will get the general solution, and when you substitute that c is find out using the initial condition. So that is substituted in the general solution, then that is the particular solution because a particular value is given to the constant. Okay, so that is the particular solution. This is how you have to find the particular solution. So first you have to separate the variables as dx and dy, coefficients of dx and dy, and then integrate it. Okay, and find the if that the integrate it, you will get the general solution. You have to put the constant on the right side. Okay, on the both sides, only one side you have to put, that is on the right side, and then find that is the general solution. And if you have given a condition y is this and x is this, then you have to put that x and y values on the general solution, and then you will get the c. Okay, c is, you will find out c and then substitute that value on general solution, you will get the particular solution. Okay, next is equation reducible to variable separable. If you have given an equation, okay, you have to reduce that to the variable separable. You don't know how to separate it, then what you have to do is, that is equations of the type dy by dx is equal to a function of both x and y, function of ax plus by plus c. Okay, then how will you separate it? That is, you have to going to study now. So in the first three type, first step is just you have given equation of x, and next equation not, it is function of x, and then function of y, and then both the functions on okay, it's a combination product of x and function of x and function of y, and now function of x and y both, okay, as a function of x and y, and that is put ax plus by plus c is equal to z. Okay, then separate the variables z and x. Okay, that is, as an example you will find it, dy by dx is equal to 4x plus y plus 1 the whole square. So both the variables are there. So first you have to put that 4x plus y plus 1 as z, and then find, then you will have the differential equation as dy by dx is equal to z square. Then separate the variables. What is that? That is dz by that is also, okay, that is dy by dx is equal to z square you have get. And then what is dy by dx? It is 4x plus y plus 1 the whole square. That is 4 plus dy by dx is equal to dz by dx. Okay, yes, you have to find the derivative dz by dx. So 4 plus dy by dx is equal to dz by dx. And now dz by dx is equal to minus 4 dy by dx, that is separated. And then dz by dx is equal, minus 4 is equal to z square, because dy by dx is z square. And then separate that. Dz by dx is equal to 4 plus z square. And then cross multiply it. You will get z in one side, dz and coefficient in one side, and x and coefficient in other side. Then integrate it. Okay, so put the value as z and then rearrange it, and then find dz by dz coefficient in one side and dx coefficient in other side, and integrate it. Okay, similarly the next question also. Okay, and the problems using these 4 types you have to do these problems. Okay, 4 types of questions are there. Okay, do these problems according to that. And next is homogeneous function. First is various separable. So there are 4 types there. Okay, so in various separable there are 4 types are very important. Okay, various separable equations, many type of equations are workout problems and also given there. Okay, please do that, and the exercises also. Next is a homogeneous function. That is, a function in x and y is called homogeneous if the degree of each term is n. Degree of each term is n. That is, f of xy is equal to x square plus y square minus xy, and g of xy is x cube minus 4xy square plus 5x square y are homogeneous of degree 2 and 3 respectively. First is a second degree homogeneous, and third is the first is the second degree, and the second is the third degree homogeneous functions. Okay, so function of x and y is said to be homogeneous of degree n if it has degree n. Okay, each term is n. Degree of each term is n. Okay, for example, and that is, and now another example, not homogeneous, which is given. H of xy is x raised to 4 minus 2xy square plus 3x square y, which is not homogeneous because the first term is of degree 4. Okay, and but the remaining terms of degree is 3. Okay, then what is a homogeneous equation? Differential equation of the form dy by dx is equal to f of xy by phi of xy, where fxy and phi of xy are homogeneous functions of xy and of same degree, then it is homogeneous. Okay, that is, the degree should be same. Okay, if the degree is same and then the homogeneous functions are xy and which the degree is same, that type of differential equation is homogeneous equation. For example, dy by dx is equal to x square plus y square by xy. X square plus y square is a function of xy, and what is the degree? It is 2. And then also xy has degree, degree 1. Okay, it is degree 1. It is not the order, it is the degree. Degree is 1. And also xy, the degree is 1. Okay, only one time it occurs. The occurring is, the recursion is the, if it is recurring, it is the degree. So it is only one time it is given. So that is, and that is the homogeneous equation. Now y by x is also a homogeneous equation because dy by dx is equal to tan y by x is also homogeneous, as tan y by x is a function of y by x, which is homogeneous because the degree is same. Okay, yes. Next is, how will you solve homogeneous equation? For that, you have to put y is equal to vx. This is a very important solution because you have to remember this. Y is equal to vx is not changing. That should be done in every problem. Okay, so but y is equal to vx, then differentiate it. Dy by dx is equal to v plus x into dy by dx, dv by dx, because product rule is applied. And then substitute in equation, we get v plus x dv by dx is equal to f of v. And then separate. dv is separated, dx is separated, and integrating it. And okay, then if we have to replace it, the general solution you can replace it. That is, the working rule is, first step is put y is equal to vx. Then separate the variables, dv, coefficient of dv one side, coefficient of dx one side, integrate both sides and replace that v by y by x. Okay, these are the 4 main steps. This should be followed in every homogeneous equation. So xy dash is equal to x plus y. Yes, x plus y. So that is, how you have to do is, y dash means dy by dx and x should be in the denominator, cross multiplication. So dy by dx is equal to x plus y by y. X plus y by x. So what is the degree? 1. So it is homogeneous. So x plus y by y, x and 1 plus y by x is there. And then put y is equal to vx. Have to put y is equal to vx and dy by dx is equal to v plus x dv by dx. Then first equation is given and you have to substitute in that both dy by dx, then to equate 1 plus dy by x, y by x is equal to v plus x dv by dx. Then rearrange that, simplify that. Coefficient of dy should be one side and coefficient of x should be one side, and then integrating it. Integral dv is equal to integral 1 by x dx. V is equal to log mod x plus c. So v is substituted as y by x. So y by x is equal to x log mod x plus c. So cross multiply. Y is the general solution. Okay. Yes, this is how you have to do homogeneous equation solution. Find solution. Okay. Similarly, the next question also. Okay. Problems. So all the problems should be done by this. First problem is 2xy into dy by dx is equal to x square plus y square. So what you have to do is dy by dx is equal to x square plus y square by 2xy. What is the degree? It is 1. So it is homogeneous. Then you have to do is put y is equal to vx. That is dy by dx is equal to v plus x dv by dx. Then equate two equations. Separate dv, coefficients of dv, and separate coefficient of dx. Integrate both sides. You will get v, the equation in v. Okay, v is equal to something. Then replace v as y by x. Okay, that is homogeneous solution. These all questions should be done like that. The last one is linear equations. Okay, the last standard form of differential equation is linear equation. So a equation is said to be linear if the dependent variable and its differential coefficients occur in its first degree only and are not multiplied together. Okay, that we have studied what are the linear equations. Example, dy by dx plus y is equal to e raised to minus x. It has order 1. Okay, so linear equation is those equation which has dependent variable and its differential coefficient occur in its first degree. First degree. Degree should be 1. Only one time the derivative is the highest derivative is occurred. One time. Okay, degree should be 1. I think understand, all of you understand. Okay, so dy by dx plus y is equal to e raised to minus x. Degree is 1 and the dependent variable and the differential coefficient are there. And next is x into d square y by dx square plus 3 dy by dx minus 7 is equal to 0, which is of order 2 but degree is 1. Also, dy by dx the whole square minus y dy by dx plus 8 is equal to 0. The order is 1 but the degree is 2. So this is not a linear equation because dy by dx is repeating 2 times. That is not possible. So that is the degree. So in linear equation we have going with degree. If the degree is 1 and the dependent variable and its coefficient is occurring only in 1 degree, okay, and which is not multiplied, okay, that is linear equations. I hope all of you understood. And then the general form of a linear equation of the first order should be. So only linear equations have general form. It has only one form. But in homogeneous also it has only one form. But in that the order should be taken. But that is the difference. In the first one, that is in variable separable, there are 4 forms there. If the function of y, function of f, function of x and function of x and y are the product, and if the function of x and y are together came, okay, that are the 4 types there. But in homogeneous there should be only one type because the order should be same. But in linear the degree should be 1. That is the 3 standard forms. So if you know the difference between these 3, you will be easy to follow that. You will easy to identify the differential equation of which kind, and then you can apply the working rule for find the solution. If many differential equation has been given for you, you have to identify that. You have to find the solution of different. Just you will give the question that find the general solution for the given differential equation. So you have to identify that in which of this standard form this belongs to. Okay, if it is linear, if it is homogeneous, if it is variably separable, then only you can apply solution, because in these 3 differential equations the solution is finding in 3 ways. In separable, it is we are going separating it, but in homogeneous we have putting a value for v. A new constant is there, a new variable is there, v. Okay, and also there is a variable in variable separable also. We have taking z as. In the 4th one, we have taken z. So, you have to identify the differential equation based on these properties. Okay, then you can easy to solve it. So, this is linear equations. So, what is the most general form? Yes, the equations of the form which is first order dy by dx plus py is equal to q, where p and q are constant. Okay, dy by dx plus py is equal to q, p and q are constant. The equations of these forms are linear equation. So you can better to be identified from the given differential equations. Now, how will you find the solution? How will you solve the linear differential equation of first order? You have in this differential equations, you have only studying the first order differential equations because the second order is excluded from your chapter. So that is why the first order differential equation is given. How will you, for the second order, the solution is of different type in another way. Okay, so in first order differential equation, how will you find the solution? To solve dy by dx plus py is equal to q, where p and q are it is not constant, they are functions of x. Sorry, there is a correction. They are not constant, they are functions of x. Okay, first you have to find e raised to integral p dx. Very important one. Okay, if you have given a linear equation, there is a p. What is p? P is a function of x. Okay, then p, you have to find e raised to integral p dx. That is the integrating factor. And we write it as if. Very important. If, that is integrating factor. And then we multiply both sides of the given equation by e raised to integral p dx. Okay, so if you have given a linear equation, first you have to identify which is p and which is q, and then find e raised to integral p dx, and then you have given that equation, take that equation and multiply both sides this integrating factor. Okay, that integrating factor should be multiplied and individually multiply that, and then what you have to do is take d by dx as constant, then rearrange it. Okay, rearrange it and then integrate both sides. You will get, yes, y into integrating factor is equal to integral q into integrating factor into dx plus c. This is the general solution for a linear differential equation. So first, the equation has to be identified as a linear equation, and then identify p and q, then find e raised to integral p dx, which is the integrating factor, and then multiply both sides by the integrating factor. Okay, and integrating factor is there, and then dy by dx into y e raised to integral p dx is equal to e raised to p dx, because that you have substituting values. And then you have to integrate both sides. You will get the answer as y. Y is there. Y into that integrating factor. Which factor you have find out. Y into integrating factor is equal to integral q into integrating factor into dx plus c. This is the general solution for the linear differential equation. For example, I will give you. Okay, there is some results also. In evaluating the result e raised to log f of x, fx is very often used. Okay, that the factor e raised to integral p dx is multiplied by left side the differential equations of the coefficient of function, differential coefficient of x and y, which is the integrating factor. So e raised to integral p dx is called the integrating factor. Okay, yes, that are not there. Then working rule is, write the given differential equation in the form dy by dx plus p dy equal to q. So identify p, obtain p and q, and then find the integrating factor if is equal to e raised to integral p dx. And then multiply, third step is multiply by the integral factor both sides, and then you integrate the both sides. Okay, you will get an equation that integrate both sides with respect to x. Then you will get y into integrating factor is equal to, you have to rearrange that solution as this. This is the required solution. this should be not. How will you the linear equation? So the solution of the linear equation, you have to put that rearrange that in this form. Okay, that is the answer. For example, find the general solution of the following equation. dy by dx is equal dy by dx minus y is equal to x e raised to x. So here, what is p? Coefficient of y, which is minus 1. What is q? X e raised to x. So that is p and q. First, then you have to find integrating factor, that is e raised to integral p dx, that is e raised to integral minus 1 dx, which is e raised to minus x. So the integrating factor is e raised to minus x. Then take the given equation, multiply both sides with e raised to minus x. Or you can simply substitute in the, okay, that is general solution is there. So you can substitute in that solution. By into e raised to minus x is equal to integral q into e raised to, q is x e raised to x into e raised to minus x into dx plus c. That is why you have to find, you have to remember the equation. I mean solution. Okay, that solution should be remembered, then you can directly substitute in that. So linear equation is very simple. Just find, first you have to identify p and q properly, and then find if, integrating factor, then integrate both sides. For instead of that, you have to substitute in the general solution. Okay, and integrate y e raised to a minus x is equal to integral x e raised to x into e raised to minus x is 1. So x dx plus c, that is y e raised to minus x is equal to 1 by 2 x square plus c. That is y is 1 by 2 x square e raised to x plus c e raised to x. Cross multiply. Okay, this is the general solution. And if, okay, then this is the proper way. And if the p and q are constants or functions of y only, there is no x, then find also integral p dy. If p is the px is there, two types of equation can be there. dy by dx plus py is equal to q. That is the first one. So dy is the dependent variable there. Okay, and then second type is the another one, dx by dy is plus px is equal to q. That same is there, but dx changes to dy. That is the equation. So the general equation, because x into if is equal to integral q into if into dy plus c. Okay, that will be there. Okay, that kind of questions also there. So identify that also. If it's a term of x and y. Okay. And another questions also there. Integral. Find the integral factor only. You have to find the integral factors only for this. Okay, then and for this also, this question also, y dx plus x minus y square dy is equal to 0. That question you have to you have to rearrange that equation to dx by dy plus px is equal to q, if you can. Otherwise y is not, that's the difference. Okay, yes. So this is the problems. Find the integral factor, and also just you have to find the if, and then next is according to the linear equations are given, find out the solution. Okay, so this is the differential equation. Very simple, but it's just little lengthy questions. The questions are simple, but the solution should be known to you. You have to identify the differential equation, which differential equation is that, then you can apply the solution very easily. Okay, so I study what is differential equation, find the order and degree, don't confuse between them, and work out more problems. I try to familiar with differential equations. Okay, Okay, I hope all of you understood the topic. Do all the problems in your textbook, practice very well. Okay, textbook problems should be very practiced by you. Then only you can solve more. If you have given any another differential equation, then only you can solve it. Okay, I hope all of you understood. If you feel any problem understanding, you can ask me. Okay, thank you, students.